Hello students, this is Dr. Asif, working as Associate Professor and Head in the Department of Mathematics in Vijaya Vittala Institute of Technology, which comes in Hennur Bagalur Road, Bangalore. Let us discuss today's topic, partial differentiation. Let us consider the example. If u is equal to 1 by r into f of r minus a theta plus f of r plus a theta, then we need to prove dou square u by dou t square is equal to a square by r square into dou by dou r of r square into dou u by dou r. Let us find all the derivatives one by one. The given function is this. Now let us differentiate u with respect to t partially first. If we are differentiating with respect to t, r will be taken as constant. So let us keep this 1 by r outside the derivative and differentiate this function and this function. Differentiation of f gives f dash of r minus a theta. Again, differentiation of this inside function using the chain rule will be taken as dou by dou t of r minus a theta. We have taken. This completes the chain rule. This completes the chain rule for f of r minus a theta plus derivative of phi is phi dash of r plus a theta into differentiation of r plus a theta with respect to t partially gives dou by dou t of r plus a theta. In the next step, let us simplify this and this. Differentiation of r is 0 because r is a constant, minus a as it is. Differentiation of t with respect to t gives 1. Phi dash, let us write this as it is. Differentiation of r is 0 plus a as it is. Differentiation of t with respect to t is 1. So this is minus a and this is plus a. We have rewritten the step here. Let us differentiate this partially with respect to t again, which gives dou square u by dou t square. Again 1 by r will be a constant. Before that, this dou square u by dou t square is nothing but dou by dou t of dou u by dou t. This can be written as this. Let us substitute this in the place of dou u by dou t and apply differentiation. Yes, we have substituted here. In this 1 by r is again taken to be as a constant, and differentiation of f dash will give f double dash. Differentiation of r minus a theta again will give minus a, but one more minus a is already there. Along with minus this minus a, it gets to minus a whole square. plus differentiation of phi dash is phi double dash. As usual, if we differentiate this, one more a will come on chain rule. Along with already present a, this gets to a square. Minus a whole square is just a square. We have written a square because minus whole square will be plus. Now you can see a square can be taken outside as constant. Yes, we have taken a square outside. Let us call this as equation number 1. This is our LHS of the equation which we have to prove. Now let us find dou u by dou r. That is dou by dou r of u. Here we need to use the product rule because we are differentiating with respect to r and we have product of two functions of r. This is one function 1 by r and this is another function of r. So we need to use the product rule here. First function 1 by r as it is, dou by dou r of the second function, this dou by dou r of this second. Now the product rule says plus second function as it is into dou by dou r of 1 by r, which we write now here. One by r as it is, differentiation of f is f dash. When we differentiate this inside function, differentiation of r with respect to r will be 1. Yeah, let us write dou by dou r of inside function as it is plus differentiation of phi gives phi dash into differentiation of r plus at, that is dou by dou r of r plus at we write here. Now we write this term as it is. Differentiation of 1 by r with respect to r gives minus 1 by r square. In the next step we simplify these two. And we multiply r square on both sides as well. When we differentiate this with respect to r, differentiation of r is 1 and differentiation of at will go to 0 because t is a constant, also a is a constant. Differentiation of constant goes to 0. And here as well, in this derivative as well, differentiation of r is 1, differentiation of at is 0. So what remains is f dash plus phi dash here. Along with that, we are going to multiply r square on both sides. This side and here. And here also we will multiply r square. Yes, we have multiplied to the one term and we have multiplied to the other term also. Now what happens? One r gets cancelled with this one r and r square gets cancelled with this r square. So what remains is r here and here r square gets cancelled. We got this. Why we multiply here? Because we wanted this r square into dou u by dou r in the required equation. That's why we multiplied. Then what we require in the given equation? In the RHS of the given equation, we want dou by dou r of r square into dou u by dou r. So for that reason, let us differentiate again this with respect to r on both sides. Now let us apply this derivative term wise. Dou by dou r of this here minus dou by dou r of this we write now. Dou by dou r of. Now in the first derivative we need to apply the product rule, you can see, because you have product of two functions. R is one function and this is another function. Let us differentiate this using the product rule. I have taken the same step from the previous slide. Let us apply the product rule now. First function as it is, dou by dou r of second term plus second term as it is. We have taken second term as it is. Dou by dou r of the second function. Sorry, dou by dou r of the first function, which is r. Let us differentiate this in the next step. Okay, here we have taken this as it is. In the same step we have taken this as it is. Now let us differentiate this in the next step. I have taken the same step from the previous slide. Differentiation of f dash, that is when we apply dou by dou r on f dash, it gets to f double dash of r minus a theta into derivative of a theta, r minus a theta, by using the chain rule. Differentiation of r is 1 and differentiation of at is 0 because we are differentiating with respect to r. Similarly, differentiation of phi dash gives phi double dash into 1 plus 0. Differentiation of r with respect to r will be 1, which we will write in the next here, which has been taken as 1 minus here. Let us differentiate this with respect to r now. Dou by dou r of f gives f dash first, and as usual this takes just 1, and differentiation of phi gives phi dash, and on chain rule differentiation of r plus at takes just 1. Let us rewrite all these by making this 1 and this as 1, which are negligible, no need to display. We'll eliminate all these and rewrite as Clearly you can see this with this positive term gets cancelled. What remains is this. Now again in the required equation in the RHS we have a square by r square into this derivative we have in the question. So for that reason let us multiply a square by r square both sides, here as well as here. So when we multiply a square by r square here, a square by r square into this, one r gets cancelled with this r, we get this. Let us call this as equation number 2. When you compare this RHS with equation number 1, this is same as dou square u by dou t square. So we are done with our problem, which says this has to be proved.